Right, let's get into a classic science conundrum. Why can't electrons be transferred from silk to a rod? Now, you've probably seen those old demonstrations. Rub a glass rod with silk and boom! Static electricity. But what's really happening here? And why doesn't silk just hand over electrons to the rod like passing the salt at dinner? It all comes down to the atomic structure of the materials involved. See, glass is what I call a bit of an electron loser. Its outer electrons aren't held on very tightly. So when you rub it with silk, those electrons are tempted away, pulled off by the silk's stronger hold. Silk, on the other hand, is more of an electron hoarder. It's got a tight grip on its own electrons and is greedy for more. But here's the catch. If you try to do the same with a plastic rod, the rules change. Plastics aren't keen on letting go of electrons, and neither is silk. It's a standoff. The electrons just aren't interested in making the jump. No transfer, no spark, nothing exciting. So the key is in how much the materials want to gain or lose electrons, a property known as their position in the triboelectric series. Silk is higher up than glass and will happily steal electrons from it. But if the rod isn't willing to play ball, like with plastic, the whole process comes to a halt. So next time someone tells you any rod and any cloth will do, you'll know that electron transfer is actually very picky. It's not just about friction, it's about chemistry and a bit of atomic matchmaking. Science isn't magic, but it's close.